Hey, this is Miss Meyer with 14.5 using the Pythagorean theorem, part 2. After this lesson, you should be able to use the distance formula. As part of this lesson, I am going to show you where the distance formula comes from. So the next thing you'll see is me deriving the distance formula. So you may understand it, you may not. I want you to try your best to follow along so that you see where it comes from. But in the end, remember that your goal is just to use the distance formula. So you'll have the formula and you'll need to be able to plug numbers into it and simplify it. You'll see the distance formula many times in math. It's really important, but do your best to follow the explanation of how it came to be and focus more on how to use it. So here we have a coordinate plane with 2 points. Now I notice I didn't put any numbers on these because we're trying to come up with a formula. So I called point number 1 over here x1, y1, and point number 2 over there x2, y2. So I drew a line between them because what we really want to know is how far apart are points 1 and 2. We're going to call that distance d, so I'm going to label that d. And from here, we're going to use the Pythagorean theorem to help figure this out, because if you could imagine drawing a straight line, horizontal line that way, and a vertical line this way, they would meet about there. And this is great because a vertical line meeting this horizontal line gives me a right angle. So I know that's a right angle. Now we also need to figure out this point here, what's its ordered pair. So think about where would this have to be on the x-axis. It's the same place as x2. And on the y-axis, it's the same place as this point over here. So that would be y1. Okay, in order to use the Pythagorean theorem, we need to know the side lengths of the blue and red sides. So the blue side goes from up here at x2 all the way down to here at x1. So that distance is x2 minus x1, whatever that difference is. For our other leg, it's going from here to there. This is y1, this is y2. So it's that difference, y2 minus y1. And if you followed up to this point, you're doing great. If you're not following completely, it's okay. Just do your best. But we need to now use the Pythagorean theorem. We need to take a and square it. We need to take b and square it. And we need to take c and square it. Put that in the Pythagorean theorem. So I'm going to replace a with this difference. And I'm going to replace b with that distance. And d, this one. Since I don't know where these points are exactly, I don't have the exact numbers, this is really not something I can do much to simplify. But since the end product I want is just plain old d and not d squared, we're going to use our friend square root. We're taking the square root of both sides. So the left side we're not going to end up being able to do much with, but this side over here, square root of d squared is just d. And so d is equal to this big crazy thing, the square root of the x difference, x2 minus x1 squared, plus the y difference squared. So again, if that whole process of deriving the formula, showing you where it comes from, didn't make much sense, that's okay. Right now, your goal is to be able to use it. You'll see this again later, but for right now, your goal is to be able to plug in two ordered pairs into this formula and find the distance between the 2 points. Okay, so we now have to use this formula. I copied it onto this screen. And then let's call this point number 1. Let's call this point number 2. I think that's the most important thing, is making sure you remember which one you've called which. So that means just, usually I do this part in my head, usually you will do this part in your head, but as a first try, let's be really careful. So I need to identify what's x1, what's y1, what's x2, and what's y2. So since my blue one I've called point 1, the x term there is 1, the y term is 5, and in point number 2, the x term, the x coordinate is -4, the y coordinate is -2. So now I need to take that information and plug it into the distance formula. So x2 is -4, x1 is 1, so the first one, so x2 minus x1 is -4 minus 1, y2 is -2, and y1 is just 5. Okay, so now I have this big expression to simplify. So let's start it off. -4 minus 1 is -5. -2 minus 5 is -7. So we've got square root of -5 squared plus -7 squared. So the good news is about all those negatives is they just go away. So we get 25 plus 49. And 25 and 49 ends in a 4. That's 74, square root of 74, which it's not in our math facts. It's not a perfect square. So the distance we can just leave as the square root of 74. Okay, so this example gets pretty crazy. It's going to combine what you learned yesterday with what you just are doing today. This one, you're going to do your best to follow it, see what you've got. But if this one's a little weird for you, it's okay. So part of why it's so weird is that there are 3 different distances you have to find. Here's what I'm going to ask. Take a minute, pause the video after you've decided which distance you want to find. You can find D1, D2, or D3. So pick one of those 3, pause the video, go off, and try and calculate that. So I solved all 3, and I left them in radical form here, and I didn't try and simplify anything, which is going to end up helping us. But D1 should be the square root of 1,800, D2 should be the square root of 5,000, and D3 should be the square root of 6,800. So now I'm supposed to prove whether or not my friend made the 90-degree turn that the friend was supposed to. So that means I have to prove whether or not this is a right triangle. So I need to use the Pythagorean theorem. And I need to say, look, is the square root of 1,800 squared plus the square root of 5,000 squared really equal to the square root of 6,800 squared? And I'm hoping that you're starting to see how helpful it is that everything is still in radical form and I didn't try and make anything into decimals. Think about it for a minute. Squaring a number, taking its square root are inverse operations. So simply to square these, it becomes 1,800 plus 5,000. Is that equal to 6,800? And when you add it up, you find out that yes, they are equal. So in fact, yes, my friend made a 90-degree turn. Okay, so your assignment today is on Khan Academy. It's called Distance Between 2 Points. It should be 7 questions. Your goal is to get to 70% or better. And if you're struggling with that, try and do 20 minutes of practice. My advice is that you write your work down as you go. This is too much of little numbers to keep in your head. And then use a calculator to help you with the arithmetic, squaring the numbers, multiplying them. Those are things that get pretty tiresome when you're doing this. So use a calculator to help try and see if you can figure out how to use this formula, and have a great rest of your day.